More than 4 billion years ago, the outer core of Mars cooled, turning off the dynamo that maintained the magnetic field. As a result, the planet was exposed to the solar wind, which ripped away the atmosphere, allowing the planet's water to evaporate into space. Mars currently appears to be a barren desert with riverbeds, deltas, and deep ocean basins pointing to the water that once existed there. However, a recent discovery has experts both excited and perplexed. Scientists are ecstatic after discovering tons of secret water on Mars. Is it because it denotes the presence of life? Or are we just a step closer to conquering Mars? Let's find out. A robotic rover recently discovered enormous amounts of water beneath the surface of Mars, which surprised many people who had previously thought of Mars as nothing more than a rocky and dusty planet. Mars is one of the most fascinating planets in our solar system. Mars is a world unto itself. One theory suggests that there was once life on this planet billions of years ago because the surface is solid. This red planet has been a popular subject of fiction and science fiction, but it is also a hotspot for researchers. The surface of Mars appears to be dry at the very least. Researchers, however, believe that up to 99% of the water is still present. Instead of escaping into outer space, it sank into the Martian sand and sandstone. All of Mars's primordial water had to go somewhere when the planet's atmosphere collapsed. This answer has always been the most straightforward, but it's also the most flawed. The issue, as the Caltech researchers were aware, is one of hydrogen. Martian water molecules dissociate into free hydrogen and oxygen atoms as they ascend into and subsequently escape from the atmosphere. In water, an oxygen atom is merely an oxygen atom, while hydrogen occurs in two forms: conventional hydrogen, which has a single proton in its nucleus, and deuterium, with a proton and a neutron. The term heavy water refers to the water molecules made up of heavier deuterium instead of regular hydrogen. Only hydrogen makes up the vast bulk of the hydrogen in the universe. However, there is a minuscule amount of deuterium. It's almost one heavy water molecule in a million in the ocean. Deuterium behaves differently in the Martian atmosphere due to its heavier weight. Free hydrogen atoms that were formerly part of a water molecule escape into space, whereas free deuterium is heavy enough to stay in the atmosphere. The ratio of deuterium to hydrogen, D to H, slowly grows over time as more hydrogen floats away from the planet and more deuterium stays behind. All of the robots that humanity has sent to Mars over the years has proven this. Since 1997, NASA has landed 5 rovers on Mars, 2 of which, Curiosity and Perseverance, are currently active and investigating the planet. Last February, Ingenuity made history by becoming the first helicopter to land on Mars. Reconnaissance, Maven, and a slew of other human-built spacecraft have been launched into Mars's orbit. Scientists are ecstatic about a new discovery found by one of these orbiters. The ExoMars orbiter of the European Space Agency has identified substantial volumes of water in the Val Marineris Canyon, the solar system's largest known canyon. According to experts, water ice could account for 40% of the near-surface material in the region of 15,830 square miles, that's 41,000 square kilometers. At a spot named Candor Chaos, a Netherlands-sized region located at the center of the Val Marineris, data from the Trace Gas Orbiter's TGO Fine Resolution Epithermal Neutron Detector, or FRIEND for short, discovered exceptionally high levels of hydrogen, which, coupled with oxygen, makes up water. Mars may have harbored life at some point in its history, and evidence of water could be a key indicator that the planet was previously habitable or that life may still exist there. For centuries, wind and water have eroded the Martian surface, smoothing out and widening the Val Marineris Canyon. Compared to the Grand Canyon in Arizona, this canyon is more than 2,500 miles or 4,000 kilometers long and 5 miles or 8 kilometers deep. According to NASA, this massive canyon would reach from New York to California if the Val Marineris existed on Earth. According to space aficionados, this isn't the first time a trace of water has been found on Mars. A vast lake formerly existed in the Jezero crater on Mars, according to the Perseverance rover's findings in October. There has been recurring evidence of frozen water on the surface of Mars over the years. We have long known that water exists on Mars, which is not a novel hypothesis. However, it's crucial to note that this specific finding holds significance for two reasons. The vast majority of Mars's water is found frozen near the planet's poles. It's possible that this newly discovered water is likewise frozen, but because it's closer to Mars's equator, it's more likely that the water keeps evaporating. This suggests that some specific, as yet unclear mix of conditions must be present in the Val Marineris to maintain the water, or that it is being replenished, according to the ESA. In order to look for signs of water on Mars, the TGO's FRIEND instrument detects neutrons emitted at or just below the Martian surface. The orbiter has been circling the red planet since 2018. The amount of water on a surface can be determined by the number of neutrons it emits, as neutrons are formed when energetic particles known as cosmic rays impact the Martian soil. Using this technology, water can be detected as deep as 3.28 feet or 1 meter below the Martian surface. The fact that it is so much closer to the Martian surface than previously thought makes this new water discovery all the more interesting. Many of Mars's water reserves are buried several kilometers below the surface and thus difficult to access. Given that this water is not too deep below the planet, future missions will find it much easier to investigate. In addition, this is a significant step in terms of Mars's exploration as a whole. Not only does this open up the Val Marineris for further exploration, but it also contributes to the already rich history of Mars. Understanding how and where water occurs on modern-day Mars is critical to understanding what happened to the planet's once abundant water supply, as well as to aid our quest for habitable conditions, possible indications of previous life, and organic elements from Mars's early days. Around 3.5 to 4 billion years ago, when life first appeared on Earth's aqueous surface, Mars possessed the right conditions to allow the emergence of life as we know it. Mars, however, did not remain livable for very long. Between 3 and 4 billion years ago, Mars lost its magnetic field, allowing the solar wind, an unceasing stream of energetic particles originating from the Sun, to impact and strip away most of the planet's atmosphere and surface water, converting Mars into what it is today. However, can we reverse the ravages of nature and make Mars habitable again? There are different opinions on the question of whether or not humanity can warm Mars's atmosphere enough to make it habitable for life. In Elon Musk's view, humanity could terraform Mars by detonating nuclear bombs on the planet's polar ice caps, for example. According to him, he claims that radiation would not be an issue since the explosion in space over the poles would vaporize the frozen carbon dioxide, which would greenhouse warm the globe and melt the ice. The prospect of nuking Mars generates a slew of scientific, ethical, and legal concerns. From a scientific standpoint, researchers predict that the melting water ice that results could easily blanket the planet to a depth of a few tens of meters, but that it would not remain long. The additional carbon dioxide that would be released into Mars's atmosphere if the planet's polar caps were vaporized would only double the pressure, a far cry from the Earth-like pressure needed to support liquid water on Mars's surface and atmospheric water vapor. More carbon dioxide can be found on Mars than on Earth thanks to the Martian soil and closely linked carbon. Researchers, however, predict that even if we mined Mars's whole surface for carbon dioxide, the atmospheric pressure would only be 10 to 14% of Earth's. An increase in temperature of roughly 10 degrees Celsius would not be adequate to sustain liquid water. To put it in perspective, we'd need to emit more carbon dioxide on Mars to warm it up significantly than we have on Earth throughout the course of our entire existence. As a result, terraforming Mars would be a monumental undertaking that, given available technology, is just not feasible. With future technical advancements, we may be able to unearth minerals deep inside the Martian crust that could contain a lot more CO2 and water. However, the size of these buried deposits is still unknown and not supported by satellite data. Even if we were to successfully introduce enough carbon dioxide and oxygen into the Martian atmosphere and maintain liquid water on the surface, the resulting Earth-like conditions would most likely be fleeting. The MAVEN mission of NASA has discovered that Mars's atmosphere is evaporating even now. Because the planet lacks a protective magnetic field, the solar wind will continue to erode its atmosphere and oceans, reverting or continuously eroding our changes. For the true terraforming of Mars, we would need to do something about its lack of a magnetic field. However, for the time being, those interested in terraforming Mars must be content with honing their concepts for the time being. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.